Hello, Algebra 1 students. I hope you are excited to get back to Topic 7, Quadratics in Vertex Form. Our goal for today is to actually solve equations. It says using square roots. So before we get started, we should probably recap what we've done so far. At the very beginning, we were introduced to the idea of a quadratic equation, right? A quadratic equation, something like this, yeah, is an equation that has a square. And you'll notice that all the equations at the beginning do have squares. Then we, for the first 2 days, said, well, I wonder what the graph of a quadratic equation looks like. And so we went through and graphed everything, and we found that the graph made a U shape. And does anyone remember the name of a U-shaped graph? That's right, it's a parabola, right? The graph of a quadratic is a parabola. It's that U-shaped graph. So we graphed those for a couple days. Then we said, okay, enough graphing. Let's see if we can go ahead and solve these quadratic equations. So we tried setting up an equation and trying to solve for x. But we ran into an issue. We didn't actually know how to undo the square that was attached to x. And so we weren't actually able to solve any of our equations algebraically. We had to, and this was in 7.3, resort to graphing. We graphed each side of the equal sign and saw where they intersected. Said, okay, well, in 7.4, last class, we needed to learn a few more things about squares and square roots. So we spent a decent amount of time on square roots, and then we learned how to simplify square roots. Well, we actually have enough information now to actually go through and solve these equations algebraically. Before we solve them, we're going to do what we do anytime we get a new type of equation. And we're going to make sure that you know how to check to make sure your answer is correct first. So, there's no point in getting an answer and then saying, well, I think that's the right answer, but how am I sure? Well, we're going to make sure we can check it, of course, using substitution. We've done this many times before, so let's take a quick peek. We're going to go through and say, well, x equals -2, that is my solution. The giveaway are those curly braces right there, shows you our nice answer. And then we're given an equation, x squared plus 6x equals -8. Well, to check our solution, we're going to go ahead and replace all of the x's with the solution. So we have an x that's being squared, an x that's being multiplied by 6. To go through here, we're going to go ahead and use PEMDAS, and that's going to be right here. We're going to use PEMDAS to evaluate or figure out the value of the left side of the equal sign. The right side of the equal sign stays exactly the same. I don't know how many steps I'll need. I'll just put maybe 3 lines down here, and you can use the space over here if you'd like. So let's go through it. Okay, so PEMDAS says do what's in the parentheses first. Unfortunately, I don't see anything in the parentheses besides -2's. There's nothing happening to the -2's in the parentheses, so that's out. Exponent is next, -2 squared. -2 squared means take 2 -2's and multiply them together. And that should give us 4. So we have 4 plus 6 times -2. Then we perform the multiplication. 6 times -2 is -12. And although you could write plus -12, -12 is the same thing. And then last but not least, no division, no addition, finish off with subtraction. We do end up with -8. Now hopefully you carefully read the directions because it says you should attempt to check the solution using PEMDAS and then check the solution again using a calculator. We are going to go back through and check each of these with a calculator. Calculator skills are extremely important for this semester and for future mathematics. However, I'm not going to do that till the end so we can do all the calculator problems at the same time. So let's just continue checking by hand. Really, at this point, you should try pausing the video and seeing if you can do the rest. However, if you do get stuck, why don't you come back here and we'll see what we can do. Ready, set, go. All right, the second one, part B, can definitely be a little tricky, especially if you don't remember what we learned last class. Last class, we actually learned that squares and square roots undo each other. We're going to learn more about that or relearn that again today. So let's say that you forgot that. And instead you said, oh, this is the square root of 3 squared. That means the square root of 3 times itself. And you're right. And then square root of 3 times square root of 3 is square root of 9. We should know we can multiply the inside of square roots. And then what is the square root of 9? Well, that's just 3. And I bet we can see that 3 minus 3 is 0. Now, the faster way to do this, using some space over here, is we could have just said a square root and square undo each other, so that just leaves you with the 3 inside, and 3 minus 3 is 0. That shortcut, the square root canceling out a square, is very important for today. Let's try a few more. X equals 2 square roots of 2 this time. Okay, so we have square minus 8 equals 0. Need a little bit more space here. A couple ways to do this problem. Go the long way first and then give you a shortcut. 2 square roots of 2 squared means do 2 square roots of 2 times itself. And then don't forget that cute little minus 8 that's hanging out over here. Now, we should also realize that the 2 and the square root of 2 are attached by multiplication. There's actually a lot of multiplication over here. And one of our foundational properties of mathematics is that we can do multiplication in any order. So I'm just going to quickly rewrite this. You don't have to do this rewrite step, just to show you I'm changing the order slightly. We know 2 times 2 is 4, and square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is just 2. So this together just becomes 2. 4 times 2 is 8, and 8 minus 8 is 0. I did promise you a faster way. We also know, or we've learned in the past, that if there's multiplication, you are allowed to distribute your square here. We're going to talk quite a bit about distributing later today. But for now, we are allowed to distribute that square with multiplication. So it ends up becoming 2 squared times square root of 2 squared minus 8. 2 squared is 4. Square root and square cancel out. 8 minus 8. And we still end up with 0 equals 0. Last but not least, this one looks scary. The answer is 1 minus 2 times the square root of 3. All right, well, let's do the same thing. So we have a big gap for x here. I'm going to do a second set of parentheses. Minus 1 squared minus 12 is supposed to equal 0. 1 minus 2 square roots of 3. Well, the first thing I see is that there's nothing actually outside this first set of parentheses. I don't even think we need that set of parentheses, so I'm going to drop those. Then, let's combine like terms. I see a positive 1 and a minus 1, so I think those two cancel. Alright, well, now all we're left with is negative 2 square roots of 3 squared. So I'm going to do that same trick last time and distribute the square to the negative 2, don't forget the minus that's there, and the 2 to the square root of 3. So this is going to give me negative 2 squared and square root of 3 squared. Let's get that square in there. There's still a minus 12 equals 0. Negative 2 times itself we did earlier, that's 4. Square root of 3 squared is 3. And this to me looks like 12 minus 12 equals 0, which is true. Now, if all of that PEMDAS stuff was a little confusing for you, it's not the end of the world, but you really should be able to track through all the work that we did without a calculator. With that being said, though, we are going to practice with a calculator. Okay, so I'm going to assume that you guys can do the first problem, A, no problem, and we're going to focus in on B right now. And in particular, I'm going to try to highlight the part that we're going to do with the calculator, because I would like you to be able to use your calculator to do all of the steps at once. Some of my students, and this is fine, would do a piece at a time. They do the square root of 3 squared, and they get here, and then they do this, and that's totally fine. But what we're going to do is do this in one fell swoop. That means all at once. So what I'm going to do then is I'm going to take this square root of 3 squared minus 3 and substitute it into my calculator. So I'm again using that TI-84 over on the side because I know it's pretty similar to your guys's. And we'll get started. We do want to try to do this exactly, and this is a good talk about some calculator etiquette. Notice that I started with a parenthesis here, and so I'm going to do the same thing on my calculator. Now, there are going to be times where you can leave off these parentheses. This is actually one of those times. But when in doubt, it's much better to overuse or use more parentheses than you need, than use fewer. Because sometimes if you're sloppy on those parentheses, your calculator, following PEMDAS way better than we ever will give you a wrong answer. So we have parentheses first, then we need that square root. Don't forget the square root is hiding above the x squared. I know it's tough to see on mine, but there's a little square root right here. So I'm going to go second x squared, and you'll see a square root pop up. Now, when the square root popped up, it automatically opened another set of parentheses. How many open sets of parentheses do we have? Well, I see 1 and then 2. All right, now we want to do the square root of 3. I want to do the square root of, that's my parentheses, of 3. And I've done that, so now I'm going to close my first set of parentheses. And so these parentheses right here are acting on the 3. So I have the square root of 3. What do I want to do next? Well, I want to square it. And so I'm going to go ahead and put an extra parenthesis. So now the whole square root of 3 is grouped, and then I'll use my x squared button. Lastly, we finish with minus 3 and hit enter to get 0. All right, let's try another. Okay. This one is important to use parentheses, and I'll show you why. Let's say that you forget these opening and closing parentheses here. And so I'm just going to go ahead and type what's there. So we have 2 square roots of 2. Well, I already have 1 open parenthesis, so I better close that one. Good practice to get into. Squared minus 8. Hit enter. Oh, I didn't get 0 here. Can you see why? Well, I did 2, whoops, that's a highlighter. I did 2 square roots of 2 squared on the calculator. Well, that means the only thing getting squared is this guy. To show the entire thing is getting squared, you must group all of that in parentheses. So I'm actually going to go back up, copy this down, and go on over. I'm going to start inserting some parentheses. Most calculators have an insert button. The TIs usually do second and then delete to access insert. That will let me put a parenthesis without deleting anything. I'm going to go over, they always insert to the front, so I'm going to do second insert on the square and do another parenthesis right here. Now we have 2 square roots of 2, and that whole thing is being squared, and when I hit enter, I get 0. Go ahead and try that last one over here. Shouldn't be too bad. I'm again going to overuse parentheses. I'm going to, and let's get rid of all this extra stuff so we don't get too confused. I am going to go ahead and put in blue this extra set of parentheses around the x right here for when I substituted. Again, you don't need that for this problem, but I really do think it's good practice for you to see where all those parentheses go. So parenthesis first, that's going to start the set of parentheses in black. Then a second parenthesis to start what I have in red. 1 minus 2 square roots of 3. Now I have 1, 2, 3 open parentheses. I need to close my first to enclose the 3 inside the square root. I need a second one to group 1 minus 2 square roots of 3. So that's the blue parenthesis that I just put. Now I need a minus 1, not a negative 1, a minus 1. I need to close the third set, 1, 2, 3, 1, 2, 3, square it, and then subtract 12. And hopefully I've done everything correctly, and we should end up with 0. Whew, we did it. Excellent. All right, so there is somewhat a longish opener, but I think it really helps remind you of how PEMDAS and your calculator, which you'll need the next couple of days, work. Now, to kind of put everything together to be successful for today, we need a few reminders and then also some updates about squares and square roots. The first thing I've already discussed, but it's definitely worth talking about again. Squares and square roots undo or cancel each other. We actually say that squares and square roots are inverses of each other because they cause each other to go away. So that means when you see this square root of 4 squared, we cancel the square root and the square, and it leaves us with 4. Square root of x squared, that's just x. Square root of x minus 3 squared, well, we do actually get to cancel these, and although you could say the answer is x minus 3, you don't actually need the parentheses. You can just put x minus 3. There's nothing happening to the parentheses anymore. All right, but there is a second property about square roots that we need for today. The second property is this. I want you to go through and decide on 2, A, B, C, if each of the statements is true or false? For example, on 2a, I'm pretty confident this is true. The square root of 16 is 4, because if I do 4 times 4, I do get back to the radicand, the number inside the radical, 16. Go ahead and try 2b and 2c and see if they're true or false. And you can try to use your calculator to assist you as well if you would like. Ready, set, go. All right, you're back. Let's see what you did. Well, on this first one, you might have been tempted to say false. I wouldn't blame you at all. But then, if you check the answer, something very weird and mind-bending happens. A negative times a negative is a positive, and that matches the inside of the square root, the radicand, which is actually the definition of a square root. We had two of the same number multiplied together to get the number inside. So, what does that mean about negative 4? Yeah, you're right. This is a true statement. The square root of 16 does equal negative 4. In fact, this is the first time we've ever seen something like this happen all year long. We are inputting the same number into a square root, and the outputs are two different numbers. What does that mean about the square root? Well, hopefully you realize that means that the square root is actually not a function. Right? Because if I ask you what the square root of 16 is, and one person, Anton, says it's 4, but then, I don't know, Beverly says that it's negative 4, well, who's right? Well, they're both right. And so that presents a bit of an issue. In fact, square roots, if you read over here, technically have two answers. Now, your calculator won't give you two answers because your calculator will only work as a function. So if you ask the calculator the square root of 16, it will always give you the positive answer. That's technically called, if you want it, the principal root. However, you, from here on out, need to realize that if you write in a square root, you need to consider or give both answers, one positive, one negative. However, and we covered this one last class, if you try the square root of negative 1 times negative 1 is positive 1, which is not negative 1. This, in fact, is, we'd say, no real solution, to which we usually just say no solution. You're not going to learn about non-real solutions until Algebra 2. So, square roots of negatives, no solution. However, square roots of positives, two answers. Now that we know all this, we are ready to conquer those quadratic equations. And we're actually on this next line going to solve a couple of them. Okay? So here's what we need. We, all year long, have been following SADMEP to solve equations. We knew that addition and subtraction undid each other, multiplication and division undid each other, but then we got to the pesky exponent. Quadratics have an exponent of 2, a square. Luckily, we now know how to undo an exponent of 2, because on part 1 we learned to undo a square, you use a square root. So let's try it. For each of these 3a, 3b, 3c, you're probably going to want to write pretty small. You want to be able to fit, I think, probably 3 lines of text down here, so be ready for it. All right, x squared equals 16. So we'll start with that one. I'm going to rewrite this, leave a little gap in front of the 16. I'll explain why shortly. We need to think, what is still attached to x? Well, there is a square still attached to x. And to undo the square, to make it disappear, to cancel it out, we now know that we can introduce or write in a square root. A square root and a square cancel each other and just leave us with x. Well, we know in algebra, whatever you do to one side of the equation, you have to do to the other. And now we can see that the square root of 16, which hopefully we know is 4, and I'll do this like so, is our answer. And it makes sense because if you check it, 4 squared is 16. So if you put this on a free response question on your test, would you get full points? No, actually, you would not. And the reason why is because you're required to find all solutions to this problem. And although 4 is a solution, we actually saw up above that the square root of 16 has a second solution as well, negative 4. So the fancy math way to do this is we actually put in front of this square root a plus and then a minus underneath. We read this as plus minus the square root of 16. And we keep the plus minus in our answer. X is equal to plus minus 4. Well, what does that mean? Well, this actually means that x can equal 4 or x can equal negative 4. And by the way, sometimes you'll see this as just x equals negative 4, comma 4 inside our curly braces. So why don't you guys go ahead and try 3b, finding both answers, and then we'll actually do 3c together because there's a bit of an issue with 3c. So try 3b, and then once you're done, unpause, and we'll come back together. Alright, hopefully for 3b you guys got x equals plus minus 3, same way we did on a, but now let's move to c, and c is particularly tricky here. You'll notice that there are two numbers attached to x here. And if we think about SADMEP, which always gives us that roadmap to how to isolate a variable, you wouldn't be punished for thinking that this minus 2 here, the beginning, right, subtraction, is what we should undo first. However, if we examine both of these numbers, this 2 here is, of course, an exponent. We start from the top, work down. This minus 2, though, is actually all grouped inside parentheses here. And parentheses is the last thing that we're allowed to do or to undo when solving a problem. So we have to undo everything on the outside of parentheses first, and so as we work down, the first thing we get to is that exponent. So we're actually going to start by taking the square root of each side. Don't forget your plus minus here. These cancel, leaves you with x minus 2 equals plus minus. What is the square root of 1? Well, hopefully you said it's 1. 1 times 1 is 1. Nothing bad at all. Now, we do still have to isolate x, and here's where things get a little bit weird, because we do, of course, want to add 2 to each side. And many of you are going to do what many of my students do, and they say, oh, and you might not want to write this because I'm going to erase it. You're going to say, oh, plus minus 1 plus 2, that is plus minus 3. And unfortunately there, you are not correct. Instead, what if I asked you a question like this? What if I said, and I'm going to use my eraser here, what is 1 plus 2? You'd say 3, and you're totally right. But then I ask you the question, what is negative 1 plus 2? And be very careful here. Negative 1 plus 2 is positive 1. And so what we often do when we're solving this plus minus sort of thing is we can still move this positive 2 to the same side as plus minus 1. We're not going to combine anything yet, though. We're actually just going to write them completely separate. So here's my positive 2. There's a plus in front, but no one writes that. So positive 2, and then plus minus 1. And then what we're going to do here is we're going to say, what is 2 plus 1? And 2 plus 1 is 3. And then what is 2 minus 1? Well, 2 minus 1 is 1. And so we get two answers here, positive 3 and positive 1. All right, well, we've gone through here and done all the important stuff for today. However, we do have a few reminders and some heads ups because eventually you guys are going to make this mistake and we're going to call you out on it, and hopefully it is a bit of fun. So starting with problem 4 here, 4, 5, and 6 are just some reminders or heads ups or just be aware of things you can and can't do. So the first thing, we learned this in topic 6, is that if you have multiplication with an exponent, you are allowed to distribute that exponent to each term inside. So 2 squared, 3 squared. Great. Same thing is that if there's division, and you'll find in math, generally if a rule works with multiplication, it also works with division, we can distribute that square. 3 squared divided by 4 squared. And even if you saw something where there isn't multiplication in between, like 5x, we need to realize 5 and x are attached with multiplication, so it becomes 5 squared, x squared. We also learned last unit that square roots are actually the same as exponents. We learned, just as an example, if I had 4 to the 1/2 power, that I could move the 2 as the index of the root, and I could keep the 1 up here, and maybe you can see that that's actually the same thing as the square root of 4. 4 to the 1/2 and square root of 4 are identical, and so because square roots are the same as exponents, it should make sense that they have to behave the same way as exponents. Like on 4a, when we had a square on the outside of multiplication, we could distribute the square. Same thing with a square root. We are allowed to distribute that square root to each individual, I guess I should say factor here, but same idea. When you have 3 of them, and we saw this last class as well, you can distribute the square root to all 3. And if you have the square root of division, and we are actually going to use this later on today, you can distribute that square root. Right? It's actually pretty easy to simplify. 2/3. It's actually much easier to take the square root of a fraction than it is of a decimal, right? If someone asked you to take the square root, this is 0.444 repeating, the square root of that, you might not realize that that's actually equal to 0.666 repeating. But as a fraction, it's much easier to see. But then we get to the last part, and the last part is a very common mistake in math. Distributive property is a shortcut, and this shortcut does not always work. In fact, you should generally assume that distributive property doesn't work. For example, if you took 3 plus 4 squared, and you just did some quick mental math following PEMDAS, we know we do inside the parentheses first, and then 7 squared is, of course, 49. This is the right answer. We followed PEMDAS. 49 is right. But let's say you did this the incorrect way, and you did 3 plus 4 squared. And you said, whoa, I love distributive property. I'm going to use it every time. It'll get me the right answer. So you distribute that square. Well, it would become 3 squared plus 4 squared. And work with me here. 3 squared is 9. 4 squared is 16. And what is 9 plus 16? Oh, well, that's 25. Does that match the answer we got originally? No, it doesn't. And we can see here, just from this quick example, that distributive property breaks down if there is any addition or subtraction inside of our parentheses. In fact, you are not allowed to distribute an exponent with addition or subtraction. You will never get, well, I can't say never, you will almost never get the right answer. And so a few more examples, because square roots are the same as squares, or at least they're both exponents, we are also not allowed to distribute a square root with addition and subtraction. We can't do it. And just one more, you might think, oh, well then subtraction we should be okay. Addition worked or didn't work. Well, addition and subtraction travel together. And if addition doesn't work, subtraction also does not work. You can't do it. And to help you remember, there's this very nice meme. There's this nice actually set of memes on the internet. I can't take credit for it. And this meme is just to remind you that you cannot do this. Right? And my students always, I think, groan and make sad eyes at me when I show this meme. There's a couple of them. There's a puppy one for this rule. There's a kitten one. There's a bunny one. They're very cute. You can find them if you Google them online. The idea here is not that I don't like dogs. I like dogs. I have a dog. I like puppies. They're adorable. And because I am a good mathematician, my puppies stay alive. And I am just trying to help you out here to make sure that you don't make a math faux pas, a math mistake. Can you see what they did wrong for this meme? Right? They said that these are equal. They took this square and they distributed inside. They said x squared squared plus 3 squared is this, which it is. But remember, we are not allowed to distribute if there is addition or subtraction. And because square roots and squares are both exponents, we are not allowed to distribute a square root either. And in fact, if I am grading your papers and you make this mistake, I am literally going to write on your paper, don't kill puppies. As you guys remind each other of this too, it's a fairly entertaining way for you to remind each other not to break these math rules. So what's wrong in the meme above? Well, we just explained that. All right, the last part of today, finally, is to put all of this together and make sure we can actually isolate x in a quadratic equation. Notice they ask us to find all real solutions to each equation. All real solutions, we should expect 2 answers in most cases. There's going to be that plus minus in there, And so from that plus minus, we will almost always get two results. So let's jump into this. We are going to be driven, or at least followed by SADMEP as we go through and isolate the variable. And we're going to explain how to see that on each problem just to make sure it's clear in your head. So the very first thing we're going to do with problem 1 is we're going to analyze which numbers are attached to x and how they're attached to x. And to do that, we identify the side of the problem with x. That's this left side, isn't it? And then we go through and we say, okay, well, there are three numbers on that side. There is, of course, a 3, a 2, and a 75. Each of those are attached by one of these letters in SADMEP. Let's make sure we're comfortable with that. Because the 3 is right next to the x, it's attached by multiplication. The 2 is a tiny number, that makes it an exponent. And the 75 has that minus in front, which means subtraction. We just read SADMEP from top to bottom, and so this should give us a nice little schedule on how we should solve. So let's get to it. Adding 75 to each side first will undo the subtracting 75. We just use the addition right next to it, and this gives me 3x squared equals positive 75. Next up, we have to undo the multiplication. All right, that's next in our line of thinking, and so we undo multiplication using division. Maybe think to ourselves, what is a third of 75? Or if you have 75 cents and you split it into 3, you get that 25. From here, just giving myself a little bit more room, a little bit of space in front of the 25, we still have the exponent, and to undo an exponent of 2, we now know that we introduce or write in a square root. Square roots and squares cancel, it leaves what's inside, which is x, and then of course we can just put our 5 and be done with it, right? Ooh, not quite. Don't forget, whenever you introduce a square root, you do need that plus minus in front of your answer. You need all solutions, and most of these problems will have 2 solutions. So let's check that and make sure things are looking okay. Right? We have 2 answers to check here, and so we have 3 times something squared minus 75 better equals 0, and of course 3 times something squared minus 75 equals 0. The 2 answers we're checking, 5 and negative 5. How do we check these? Well, now we're going backwards, right? We did SADMEP to isolate x. Now we're essentially unisolating x. We're trying to figure out the value of an expression, so now we follow PEMDAS. And we do what's in the parentheses first, but there's nothing to do in the parentheses. There's just a 5 and a negative 5. So we're on to exponents. So that tells me we have to do 5 squared, or 25. Same thing over here. Negative 5 times itself. Negative times a negative is a positive. And we're here. Next up, we have multiplication. That will be 75 on each side. And I'm pretty confident you can finish this one off as 75 minus itself is 0, and 0 does indeed equal 0. We saw each of these answers does give the correct left and right side. You're not going to have to check every answer today, but just the first couple to make sure you understand the process. Let's move on to our second one. SADMEP again. Very, very similar problem to the first one, and honestly, I bet you guys could probably pause this and do this on your own and then just skim forward to make sure you did it right. That way you don't have to listen to me talk you through it. Here we go. 3, 2, and 11. The 3 is multiplying, the 2 is an exponent, and the 11 is subtracting. Let's undo the subtraction first, like so. Gives us 3x squared equals 72. And then we can go through and divide off the 3. That is the next in our line of SADMEP. So we divide off that 3 here. Might have to do a little bit of math, but I think you'll find that a third of 72 is 24. We still have a square, so we should probably undo that. Square root plus minus. And we end up with x equals plus minus, what is the square root of 24? 4 times 4 is 16, 5 times 5 is 25, somewhere between 4 and 5. Oh, well, that's kind of nice, though. It's not a nice number. So that means we actually just get to keep it as the square root of 24. Or do we? Remember, each time we get a square root, we should really check to see if we can break down that square root. And one of the easiest ways to check that is to look at that factor list that we've discussed before. So what are the factors of 24? Well, 1 times 24 is a factor, 2 times 12, right? 3 times 8, and 4 times 6. The way we can tell if we have to reduce this square root is we go through and we say, well, are any of these perfect squares? And we don't talk about 1, so that one's out. 24 is not a perfect square. We don't know the square root, nor is 2, nor is 12, nor is 3, nor is 8. Ooh, but 4. 4 is a perfect square. And so that's really a giveaway that we can break down 24. If there are any perfect squares in there, we can simplify this guy. Now, we could use the tree method, and I'll try to do it in 2 different ways today. But since I just discussed how there's a perfect square, let's rewrite the square root of 24 using the perfect square, 4 and 6. And then, without killing puppies, we can distribute the square root here. We can do that because there's only multiplication, and that gives me 2 square roots of 6. So my final simplified answer, still plus minus, is 2 square roots of 6. All right, let's check our answers over here. We have 2 answers. Let's make sure we're comfortable with it. We'll only go kind of part way with one of them because I think eventually they're going to turn out looking the same. 3 times our x squared minus 11 equals 61, and I'll do the same for both. There we go. 2 answers to check. 2 square roots of 6 and negative 2 square roots of 6. All right, PEMDAS, there's nothing to do in the parentheses, but there is an exponent. So we could do 2 square roots of 6 times itself, but we should also remember these are attached by multiplication. We can distribute a square as long as there's only multiplication here, and there is only multiplication here. So this is going to give me, we'll keep the parentheses for now, 2 squared and the square root of 6 squared, minus 11 equals 61. Same thing on the other side, but I'm going to be particular with my parentheses and make sure this negative 2 is in parentheses, another set, just to make sure that we take care of the negative appropriately. I don't know why I have another square here. Whoops. There we go. All right, 2 squared is 4. Square root is 6 squared. Square roots and squares cancel. That just gives me 6. Okay. Minus 11 equals 61. And then we can multiply this out. 6 times 4 is 24. And 3 times 24 we discussed earlier is 72. 72 minus 11 is 61. You'll notice we pretty much get the same thing here. Negative 2 times itself is 4. This is 6. And I think we've already matched what's on the other side. There's no reason to do the rest. So hopefully we're getting the hang of this. We're going to try one more where you have to check the answers. And then for the rest of them, you guys are just working on solving. Okay, so 3, we'll do the same idea. SADMEP again, and I am going to do this every time just to really hammer home this order because this is the most common mistake I see students make. They just go out of order and they try to divide first, or they square root too early and they end up getting the wrong answer. Even though they generally know what they're doing, that order really messes with their answers. So exponent of 2, it's down here. We have a 4, that's multiplying, and we have a 1, which is subtracting, very similar each time. We'll add 1 to both sides. And that takes care of my subtraction. There's no addition, no division. So we're down to 4x squared equals 1. Our 4 is multiplying. And we still have the exponent of 2. So let's go ahead and divide off the 4. And we have to do that to the other side as well, I think. Now we are taking 1 and we're splitting it into 4 even parts. Think about $1 split into 4 even parts. And you might be tempted to say, oh, that is 0.25. And you're right. 1 split 4 ways is 0.25 or a quarter. However, it's going to be easier for us to leave it as the fraction 1/4 that we saw up here because we still have the squared attached. And if we still have a squared attached, we need to undo it, of course, using a square root. It is easier to square root fractions than it is decimals. Okay, plus minus 1/4 here. We are going to use our distributive property. Still no killing puppies though. We're going to distribute that square root and end up with 1/2. Not bad. Let's check our answers. Same idea again. We won't go the whole way through, but we'll just make sure we're comfortable with this. I think it'll be more clear this time that we're working backwards, right? We need to check positive 1/2 and negative 1/2. First thing we do is we square. To square, we are allowed to distribute here, so it's going to be 1 squared over 2 squared. 1 squared is 1, 2 squared is 4. We'll do the same thing here. Now with this negative, we want to either move the negative to the 1 up top or the 2 down below. Your choice. I'll move it to the 1. So it becomes negative 1 squared over 2 squared. Okay. Negative 1 squared is 1, 2 squared is 4. And now these two sides are the same, so I'm just going to keep working with one side. 1/4 of 4 is just 1, and 1 minus 1 is 0. Ta-da! All right, done with checking those answers. Let's go ahead and work the rest of these. So, problem 4, SADMEP. There are 3 numbers attached to m. We have that square, which is our exponent, no surprise. We have our 3, which is subtracting. And then we have our 15. And how's the 15 attached? Well, remember that fractions mean divide. 15 is attached to m by division. So a little bit different than what we've done. However, the first step is still the same. Add 3 to each side. Leaves us with m squared divided by 15. And we said negative 3 plus 3 is 0. I even wrote the 0 down here, and I should probably do the same here. It's also 0. Of course, we don't want to leave one side of the equal sign empty, so we just put in that 0 as a placeholder. Now we still have a 15 that's dividing and a square that is an exponent. We will need to undo the 15 that's dividing. How? Well, with multiplication. Now, when we multiply, and I see this a lot on students' papers, a lot of times students will multiply the 15 by the 15 down below in the denominator. That's not what we want to do. That doesn't cancel out the division. We need to multiply the 15 by the m squared, right? Technically, you should even probably just do it like this, because now the 15 is attached to m by multiplication, and this 15 is attached by division. And by doing that, we can cancel each other out. Same thing over here. M squared equals 0 times anything is 0. We still have this square. Use a little bit more space over here, leave a little gap, and we want to square root each side. Plus minus, they cancel, m equals, oof, and then a bit of a pause. The square root of 0 is what? Well, what times itself is 0? I think 0 times 0 is 0. And so although you can write plus minus 0, we see those two answers, really everyone is just going to say 0 because positive 0 and negative 0 mean the same thing. All right, on to problem 5, and I'll write this out over on the side. Hopefully you get sick of seeing SADMEP and you just start to see it in your mind each time. It really does help us. So let's go through and think what's attached to the y. Well, of course, there's a square. I'll continue with the trend of using blue for the exponent. And then you are going to say, well, there's a plus 3, and you're right. There is a plus 3, but the plus 3 is trapped inside the parentheses. And because we have to work from the outside in, and parentheses are way down at the bottom, we can't actually get to the plus 3 until the very end. So what do we do to begin? Well, we start by undoing the square, the only thing we can do before the parentheses. Undo that like so. Same thing on the other side. And don't forget your what? That's right, plus minus. Okay, these cancel. Y plus 3 equals, we should probably know that the square root of 49 is 7. And we're almost done. Now there's only one value attached to y. That's the 3 we were discussing before. We can subtract 3. And then true or false, you tell me. Is plus minus 7 minus 3 equal to plus minus 4? No, it is not. We need to remember that what we did on the previous page, we're just going to take that negative 3 that's over here, and we're going to just set it gently in front of the plus minus 7. This is our answer. Now, sometimes it's nice to see the individual answers, and in fact, I gave you the answer on this one and actually most of the others, so you can see how you're doing. I like to just write this out, and I say, well, y equals negative 3 plus 7, and then y equals negative 3 minus 7. Once you're here, hopefully it's pretty clear that 7 minus 3 is 4, and negative 3 minus 7 is negative 10. And then you can see our two answers. So by splitting the plus minus at the end, it gives us a nice way to visualize both of those answers instead of getting a little confused about the plus minus. Let's move on. 4 to go. All right, 6. We're kind of putting most of this together. So back to our SADMEP process. And let's think about what's attached to x. Well, we of course have our square. Can't get rid of that. We have our 6, which is subtracting. And then we just have our parentheses over here, which are preventing us from getting to anything on the inside. Okay, so we undo subtracting 6 by adding 6 to each side. This gives me, let's see here, x minus 2 squared, 31 plus 6, I think is 37. Still two values attached to x, and to get to them, the next step we're going to do is take that square root. I'm actually going to quickly rewrite this just for clarity, make sure it doesn't get too squished on the screen. So we'll introduce that square root, which means we need a plus minus. Square root and square cancel. X minus 2 equals plus minus square root of 37. So then we need to quickly ask ourselves, can we break down the square root of 37? Well, I'm thinking we can't, and there are two reasons. First, if you look at your factor list, I think the only thing that goes nicely into 37 are 1 and 37. It means 37 is prime. There's no square, perfect square hiding. There's actually nothing we can break that down with. And if you look at the answer, there's already a square root of 37 in the answer, which is a pretty good indication that we don't have to break it down. So I think we just have one step left. Let's finish isolating x by adding 2 to each side. And just be careful here. I've seen some students say, oh, 2 and 37 is 39. And although you're not wrong, the 2 is outside a square root, 37 is on the inside. We can only add square roots when both terms have the same square root. Since 2 doesn't have a square root of 37, this positive 2 is just going to sit right in front of the plus minus square root of 37, which is how we get to our answer. All right, 7. 7, 8, 9, I think kind of put everything together here. It really lets us use most of the letters in SADMEP, so let's see them all. We have our 1/2, which is right here. That is attached to the parentheses and to the x by multiplication. We, of course, have our parentheses. Okay, looks good there. We have an exponent. And we, of course, have a minus 8. Look at that, 4 different parts of SADMEP. Let's go through and undo each. We undo the addition and subtraction first. That leaves us with 1/2. And then we have our parentheses, x minus 1. We have the square, and I'm just color coding this way this time, equals 8. The next thing we have to undo, and this one's a little bit backwards, we think multiplication, so we could undo with division. And you are right, but hang off on writing this. You could divide both sides by 1/2. But I find my students tend to get into trouble when they try a number divided by a fraction like this. It's very doable, but instead I think the more efficient way is we just take the reciprocal 2/1. And of course, whatever we do to one side, we do to the other. 2/1 is just the number 2, though, so we should probably leave that. That's going to get rid of the 2's and the 1's, and leaves me with x minus 1 squared equals 16. Took care of the multiplication and division. Next, we undo the square. Square root, right? That's our exponent we're undoing with plus minus. Square root and squares cancel. X minus 1 equals plus minus the square root of 16. We know that one is 4. Close to finishing this off, we can now undo the subtracting 1 by adding 1 to each side. And this isn't going to trick you this time. We just take the 1. We know it doesn't combine with the 4. They sit right next to each other. To find our final answers, I just like to make 2 lines like this. And we say one of them is 1 plus 4, that's clearly 5. And the other is 1 minus 4, negative 3. You do need to include both answers here to get full points. 2 to go. All right, question 8. I bet at any point you guys can probably pause this and do the last couple and then just unpause and fast forward to see how you did, but I'm happy to continue working through the problem with you. So we have our exponent, and we have that multiplication. We also have some addition, and then of course we have this a plus 5, which is grouped in the parentheses. So let's begin. Subtracting 24 first. All right. That leaves us with negative 3 times a plus 5 squared equals negative 24. The next thing we have is that negative 3 that's multiplying by everything, which means we need to divide by negative 3 on each side. This leaves us with a plus 5 squared equals, this looks like positive 8. Still have a square, and still have some parentheses to deal with. So we undo the square with the square root. Don't forget your plus minus. Leaves us with a plus 5 equals plus minus the square root of 8. And the last step, of course, is to undo that adding 5 now that the parentheses are down. Don't forget we cannot combine the 5 and the 8. They're just going to sit right next to each other. Okay, hopefully you've noticed that that square root of 8 does not match 2 square roots of 2. And the reason is because we do need to simplify or reduce or break down that square root. The way we could check that is we look for the factors, 1 times 8, 2 times 4, and that 4 is a perfect square. That means we're going to be able to break down the square root of 8. And I'll give you the other method we learned a few classes ago, actually last class. We can break this down. It doesn't matter how you break it down. I'll do 4 and 2. We broke down the 8, so cross it out. Break down the 4. That becomes 2 times 2. And so we can say that the square root of 8 becomes, here's a pair of 2's. We learned that the pair is going to sit outside in just a single 2. And then we have one singleton, no pair, which goes on the inside. So a square root of 8 is actually 2 square roots of 2, which is why our final answer is negative 5 plus minus 2 square roots of 2. Last one. Whew. Finally, lots of good practice here today. All right, SADMEP once more, and that'll finish it off for today, at least until you get to your independent practice. So, negative 2 is multiplying. We have our parentheses here, and a nice old exponent, and of course a little bit of subtraction. Start with the subtraction, undo it with addition. And we end up with negative 2 times x plus 7 squared equals 8. Here we still have an exponent and some multiplication and of course some parentheses. And I missed my colors on that one. Whoops. To undo multiplication, we'll divide. There we go. X plus 7 squared equals negative 4. We still have two numbers attached. We have a square and these parentheses, so we of course tackle the square first. Square root, don't forget your plus minus. Leaves us with x plus 7 equals, let's see, what is the square root of negative 4? Is it negative 2? Let's see, square root of negative 4, is it equal to negative 2? Well, let's check it. Negative 2 times negative 2, oh, that's positive 4. That doesn't give us a negative. Any ideas here? Well, hopefully you remember also from last class that we actually cannot do the square root of a negative this year. We say it's not a real solution. And in fact, if you try that on your calculator, you'll get an error. So if you get an error, and I'll write a little note about this, we usually say does not exist. And if you're in the middle of solving a problem and a valid algebraic move like this one gets you a does not exist answer, then that actually means that there is no solution. There is no way that we can make this true. So you should put no solution, and that's all you need to do. There is no number that you know, at least this year, that when you replace x with it, will make the left side equal to the right. That happens anytime you end up square rooting a negative. So thank you for working through all these problems with me. Sorry for all the different colors, but I really do think that they help my students say that they like them at least. Don't forget our meme here. This is going to become more and more important over the next few weeks, and I appreciate you learning algebra with me. We have one more lesson on topic 7, and it's really going to tie everything together that we've done for all of topic 7. We're going to go back to graphs. We're going to be solving equations. It's a really good tie-in to conclude this unit. So I'm excited to have you back for topic 7. Keep up the great work.